The astronaut who steps onto the rocket is not the same astronaut who steps off it months later. Their bones have changed. Their heart has changed. Their eyes have changed. Their brain has shifted inside their skull. Even the way their genes behave has shifted. Spaceflight is one of the most extreme things a human body can experience. And once you understand what space actually does to us, you may never look at astronauts the same way again. The human body was built for Earth. Every bone, every muscle, every nerve, every cell shaped over millions of years to deal with one specific force: gravity. Take that force away, and the body begins to take itself apart. Not all at once, but quietly, cell by cell. And it begins within minutes of leaving Earth. The moment an astronaut floats into orbit, the fluids inside the body lose their downward pull. Blood, lymph, water. All of it begins to drift upward, toward the head. Within hours, the face becomes round and puffy. The legs thin out. Astronauts call it moon face and chicken legs. The sinuses fill. The voice changes. And the body, for the first time in evolutionary history, has no idea which way is up. Within a day or two, space motion sickness sets in for most astronauts. Nausea, dizziness, disorientation. The inner ear, which controls balance, panics. Sleep becomes broken. The International Space Station orbits Earth every 90 minutes, which means 16 sunrises and 16 sunsets in every 24-hour day. Taste fades, and many astronauts crave spicy or strongly flavored food just to feel something. And then, the deeper changes begin. Because the body is not just adjusting, it is slowly reorganizing itself for an environment humans were never meant to inhabit. Without gravity, bones lose their job. On Earth, your skeleton constantly renews itself, depositing calcium into the bones that carry your weight. In space, that signal disappears. Astronauts can lose roughly 1 to 1.5% of bone mass every single month. That is the same rate seen in elderly people with severe osteoporosis, happening to healthy adults in their 30s and 40s. A 6-month mission can age a skeleton by years. Some of that bone returns when they come home. Some of it never does. Muscles vanish almost as quickly. Without the resistance of gravity, the legs, back, and core stop being used the way they evolved to be used. Without aggressive daily exercise, astronauts can lose significant muscle mass within just a few weeks of microgravity. That is why crews on the space station train for 2 hours every single day, lifting weights they cannot feel, running on treadmills strapped down with bungee cords, just to keep the body from forgetting what it is. And then there is the heart. On Earth, your heart works against gravity to push blood upward. In space, that resistance is gone. The heart, no longer fighting, begins to shrink. It also changes shape, becoming more spherical. Astronauts often return with hearts that are temporarily smaller and somewhat deconditioned compared to before launch. For most, it recovers, but recovers does not always mean the same. And then there is something stranger. Something doctors are still trying to understand. Something that affects the eyes and the brain itself. After long missions, MRI scans have shown measurable upward shifts of the brain within the skull. The fluid-filled chambers of the brain, the ventricles, expand. Some of these changes persist for years after returning to Earth. Astronauts also experience something called SANS, Spaceflight-Associated Neuro-ocular Syndrome. Pressure inside the skull pushes on the eyes from behind. The optic nerve swells. The back of the eyeball flattens. Vision blurs. For some astronauts, those vision changes may persist long after returning to Earth, sending them home needing glasses for the first time in their lives. There is one change that sounds almost funny. Without gravity compressing them, the discs of the spine relax. Astronauts grow taller in space, up to 5 centimeters taller, but back on Earth, gravity returns. The spine compresses again, and many astronauts experience severe back pain in the weeks afterward, sometimes leading to herniated discs. The body that floated in orbit is longer than the body that has to walk again. But the most disturbing changes are the ones you cannot see, the ones happening down at the level of cells and DNA. Even on the space station, high above Earth's thick atmosphere, astronauts are bathed in cosmic radiation far stronger than anything on the ground. In a single day in orbit, an astronaut can absorb as much radiation as a person on Earth might absorb in months. This radiation can damage DNA and other cellular structures. It increases the long-term risk of cancer. It alters how genes are expressed. And it can wake up viruses that were sleeping inside the body, like the herpes virus or the chickenpox virus that many astronauts have carried since childhood. Once awake, those viruses can shed for weeks. NASA conducted one of the most fascinating experiments in the history of medicine. Astronaut Scott Kelly spent nearly a year on the space station. His identical twin, Mark Kelly, stayed on Earth. When Scott came home, scientists compared the two brothers cell by cell. They found that nearly 7% of Scott's gene expression had been altered, and some of it never returned to normal. His telomeres, the protective caps at the ends of his chromosomes, changed in unexpected ways. His cognitive performance dipped after returning. His gut bacteria shifted. The brother who came home from space was biologically no longer quite the same person as the brother who never left. And then there is the part no scan can measure. Looking down at Earth from orbit changes people. Astronauts call it the overview effect. A sudden, overwhelming awareness of how thin the atmosphere is, how fragile the planet looks, how small every border, every conflict, every worry seems from above. Many astronauts return with deep emotional or philosophical shifts. Some leave their careers. Others spend the rest of their lives trying to describe what they saw. The body returns. The mind never quite does. And remember, everything we have just described happens inside Earth's protective bubble. The space station orbits just 400 kilometers above us, still shielded by the invisible magnetic field that deflects most of the deadliest cosmic radiation. A mission to Mars is different, 2 to 3 years long, far beyond rescue and far beyond that magnetic shield. Out there, astronauts would be exposed to radiation no human has ever experienced for that long. The astronauts who one day walk on Mars will be the most studied human beings in history, because no one truly knows what they will become. So the next time you see an astronaut wave from a returning capsule, remember, they are not who they were. They went to space, and space went into them.